All right, so you teach me. You should have been doing it in homework all weekend. You should have been doing it for all of conic sections. What do you do when they give you clues first? Two things. Get a graph in standard form. That's what I would say. Get a graph in standard form. Now, standard form, wouldn't you need to know whether to put x first or y first? That's why I would say, technically, Tony, you probably think through it. But for most people, I would say get a graph first. Because when you get a graph and you realize, hey, you go left 2, up 1, and then you go right 2, up 1. And what are these again? What were they? Vertices. So vertices, why am I going to automatically say, oh, no big deal, I'm using y-its? It's horizontal, right? Cool. And what did we figure out next in the example on Friday? The center is at 0, 1. Perfect. So that's my HK. So I can do x minus 0 squared all over minus y minus 1 squared all over equals 1. How do we figure out A? Distance to the vertices, so 2 and 2. So I can put 2 squared, which is 4. B. Oh, it doesn't tell me my B. Oh, they tell me 5, 4. So 1, 2, 3, 4, 5. 1, 2, 3, 4. They give me a point? So that's a random like x, y? They didn't tell me the foci. I couldn't even find C this time. But I can go ahead and plug in my 5, 4 and say, okay, well, fine. If I know the point 5, 4, plug it in, right? Okay, so if I plug in, what do I get? I get 5 minus 25 over 4 minus, and then 4 minus 1 is 3, and 3 squared is 9. Did you guys subtract that to the other side? We could do that. So 4 over 4 minus 25 fourths. That'd be negative 9 over b squared is equal to negative 16 all over 4. You guys agree? Did anybody do a little bit of cross multiplying? Oh, I can't subtract? Well, that's really lame. I was doing 25 and 9. Oops. I was thinking Pythagorean triples. Sorry. Lo siento. Now can I cross multiply? Do you guys know what cross multiplying is? Are we okay? It's basically just moving the 4 up and moving the b squared up, right? It's just move up, move up. Now you can divide, so b squared is equal to negative 36 over negative 21. The negatives cancel. 3 goes into both 12 times and 7 times. Is that right? So then can I put a, oh, hey, if b squared equals 12 sevenths, I could square root, or couldn't I just plug it in for b squared? So then we end up with, now hold on. With all your work with all of these things, I can do x squared all over 4 minus y minus 1 squared all over. Would they want you to put 12 sevenths in the denominator and leave it like that? Dividing by a fraction is multiplying by the reciprocal. So then we end up with 7 over 12. 7 over 12. Does that match up with what we did on Friday? What we? Well, past me and present you. Well, I guess now it's past you also. Whoa. Jason. Then that's done. So what was going on in this next example? What was different? He had to do complete the square. But didn't we use Kyle's trick, even though I didn't mention it as Kyle's trick because Kyle wasn't in Honors Pre-Cal last year. But wouldn't we group things, cool kids? Oh, was he the one answering? Why did I leave lots of little blanks? But don't we have to take away the coefficients first for complete square? So we end up with y squared plus 4y plus half of 4 is 2. 2 squared is 4. And wouldn't that be the same thing as adding, oops. Adam, say it loud and clear. Why am I going to put a positive 64 over here if I only put a 4? Yeah, you got to look on who's on the outside. When I put in a 4, it's really a 64 to make it balance. And then I'm going to pull out a negative because I need this to be a positive. X squared minus 2x plus, what goes in that blank? A 1, true? But doesn't that mean I need to put a negative 1? What do you mean equals 0? I mean, this is all nice. It's y plus 2, quantity squared, minus x minus 1, quantity squared. I'm ready to divide. It's a degenerate. Those degenerates. Those degenerates. So question, is this a hyperbola? Nope, because I can't make it equal 1. Yeah, I can add 1, and then you just mess up your whole form, because plus 1 doesn't go with this guy. Well, then who is he? He's a parabola? No, he's not, because there's 2 squareds. He's a line? He's 2 lines. Why? It's not a hyperbola. But if we were to go ahead and something like, I don't know, couldn't we move that guy to the other side to try to figure out who this is? And couldn't we plus or minus square root both sides? And then wouldn't we end up with a plus or minus? Well, let's put the plus or minus on. We only need it on one side. 4 equals plus or minus. Couldn't we divide by 4? Couldn't we subtract 2? And don't we get y is equal to plus or minus 1/4? Now to get these, we'd have to do, let's see, positive 1/4 x, so positive 1/4, and that'd be a negative 1/4, or negative times a positive. Minus 2 minus 8/4, that'd be negative 9/4. There's one. Then the other one, we'd have to do like an or. And then we go the opposite direction, which would be a negative 1/4 x. Negative 1, positive 1/4, 8/4, negative 7/4. It was a very, very, very hidden 2 lines. It was a very, very, very hidden 2 lines. Kim? Oh, you missed it when we were explaining it? When you put the 4, it's really a 64, 16 times 4. Oh, I didn't move it. I didn't move it. I'm keeping it balanced. Algebra, what you add to one side, add to the other. So it's not same side where it's positive, negative. It's opposite sides. Does that make sense? Kyle?
Well, I had a question when we did it yet on
Friday. Mm-hmm.
Could this be considered the asymptote, or are those 2?
Right. What I'm in my head, I'm actually not doing the math of the asymptotes, which I guess I could be. In my head, what I'm doing is I'm going back to where all conic sections came from. You guys know what I'm talking about, right? Section 10.2. Section 10.2 at the very beginning. Remember all those pictures with the double-naped cones? Didn't it show us some degenerates? Ooh, here it is. It showed us some degenerates. Intersecting lines, right? So what I'm in my head thinking, I'm thinking, would a hyperbola have asymptotes that were the intersecting lines? Just so you know where my brain is. Would the hyperbola have asymptotes of the intersecting lines? Possibly and possibly not. So if you're thinking of the maximum hyperbola, like the one, because depending on where you slice it, do you see where these slices will be smaller than if you were to slice farther in, farther in, farther in? Okay, so these are only the asymptotes of the very, very middle. Does that make sense? So these are only the asymptotes of the very, very middle hyperbola, which is not actually a hyperbola. So as soon as you start coming out, the hyperbola is going to get narrower and narrower, so the asymptotes are going to get narrower and narrower as well. So you can think that these are the, if you get all the way to the edge, it's like the asymptotes or the hyperbola has come to a straight line because there is no hyperbola anymore, it's just a point. So somewhere between the vertical line and these intersecting lines are all the asymptotes. It's like a range rather than like an actual asymptote. But a good question, very good question. All right, let's go ahead and go back to, bloop, 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 bloop. Does that finish up our notes for section 10 point? Oops, nope, that's ellipse, sorry. 10 point, here we are. Yeah, and that gets us to homework, true? Color pens, homework spirals, let's grade. And then we gotta get back to quadric surfaces. Homework spirals, color pens. Let's see where you got stuck on homework. And maybe some of it was what you just saw. Whoa, section 10.4. Wasn't there a section that said kind of like, hey, here's the messed up multiplied out No completing of squares has happened yet, and tell us what conic it is. Yeah, I need to figure out, was it an ellipse, was it a hyperbola, was it a parabola, etc., etc., etc. Yeah. That was a great section. P.S. for the test. That's a great section. Test. Woo! All right, what's going on in our calendar? You heard me, I think, on the video on Friday, at least a little bit, talk about how we're not doing our section 10.5. Okay, instead we're doing another section from another book that is more helpful for calculus. And if you ask the Calc AB kids right now what test they just took, if they remember it, what we're going to do in the other book, section 12.3, quadric surfaces, is what they just had to think about for their last test of the year, or their last new content test of the year. Now we're AP reviewing. But anyway, that's kind of cool in that they were like, oh, it's like the things from last year that you spun. I was like, yeah. So anyway, what we're about to do is from another book. It's another variation, another way of ending the chapter. Our book is cool and all, and it does get one step harder by rotating conics just by moving the axes to be horizontal, vertical, to being slanted. But the other section we're going to do instead of just rotating the axes so everything is tilted, instead we're going to, literally be revolving from the second dimension to the third dimension. That's much more helpful as far as future maths. Kind of like how we're skipping the three-dimensional vectors, because it's not super helpful for at least where we're going towards calculuses. Helpful for physics, but not for the other. We have to kind of narrow down. That's similar to what we're doing here, except this time we're going to the third dimension instead of staying in the second dimension. For vectors, we stayed in the second dimension instead of going to the third dimension. Anyway, in case you were caring. But this is the final section towards our Chapter 10A test, which is going to be sections 10.1 to 10.4, and the other book, what we're working on, quadric surfaces 12.3. You're like, but there are more sections besides 10.5. Yeah, there's a 10.6, 10.7. You know how I told you pre-cal? They're taking a test on Chapter 9, like all the sequences, series, binomial theorem, and probability is a separate little quiz. That's your Chapter 10. So Chapter 10 test is going to be all the conic sections, including the three-dimensional one. And then we're going to have a little quiz on 10.6, 10.7, polar and parametric, the other two modes in your calculator. And you can ask BC what they're having to review right now. And guess what? It's polar and parametric. What you're doing does have a purpose. All right. Let's grade. You guys ready? Anyway, did you see when your test was? Thursday. So when I say something about homework in that cool section that just said, hey, which conic is helpful for the test, I mean helpful for the test. I mean you should be thinking about the test. Yeah, Johan, what's up then? They're actually graded and marked. I should be having Rachel do that right now. I need my TAs to help me with writing down the scores, and they'll give them tomorrow. Thanks, Ben. You'll probably get them Wednesday. But corrections won't be due until after the Chapter 10 test. You'll probably get them Wednesday. But they should get in RenWeb tonight, I think. Yeah, I was catching up this weekend in lots of ways. Here we go. You guys already grade 6 and 8, C and D? Number 10, final answer, x squared over 16 minus y squared over 20. You had some nasty square roots, but square the square roots, and then they get all pretty again. Number 26, was a full get all the way to the sketch. So let me give you some moments. Let me get you some moments to check all of your, because you had to identify everything, right? The center, the vertices, the foci. Whoa, look at the asymptotes. Whoa. Some of you would have just done m equals. But what did they do? Were they identifying just the slopes or the actual asymptotes? What's the difference? They made the line. They made the equation of the line. Don't you see point slope? I see point slope. There's my m, my plus or minus. Which way was which? B over a, my plus or minus b over a, times x minus x1 equals y minus y1. They just moved it over and said, forget it, stick it to the man, we're done. That's exactly what we do in calculus too. They didn't even distribute, and then they're like, forget it. They made the lines, not just the slopes. So you guys had some odds in the back of the book, right? You should have seen the lines, but just explaining. They did the lines, the actual lines of the asymptote. Number 42. Did you guys get the clue of C? But did you figure out it was only possible if B was 6 and A was 8? This one's tricky. A lot of people would have said 3 and 4. It wasn't 3 and 4. It was 6 and 8, which is also 3/4. Ooh! The slope reduced. Because the only way to get 10, a distance of 10, 3 and 4 don't make 10. Wait, what am I talking about? Isn't there a formula that relates A and B and C? A squared plus B squared, 9 and 16 is 25, not 100. But 36 and 64 makes 100, and it makes 3/4. Oh, tricky, 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 tricky. So remember, when you do the slopes of the asymptotes, it does get reduced. So just because you see 3/4, it could have been 6/8, it could have been 9/12, it could have been, I don't know, any multiple of 3. Oh, that's what they're doing here. Any multiple of 3 and any multiple of 4, it could have reduced to that. Tricky. Questions on this one before we leave, because he's tricky. If you thought it was 3 and thought it was 4, that was good, except you didn't realize this 10 is impossible with 3 and 4. Had to be 6 and 8. Okay. Which is why you guys see over 64 and over 36. 54 was a circle. Pourquoi? Pourquoi? They're both squared, so it can't be a parabola, can't be a line. It's a plus, so it can't be a hyperbola. And what are their coefficients? 1s. But how do you make sure it's not a degenerate? A degenerate? Yeah, look at this guy. Didn't this guy look like a hyperbola? They're both squared. There's a minus. It's a hyperbola, right? It wasn't a hyperbola, because what happened? So how would you have double-checked it looks like a circle, but how do we know it's actually a circle? There are things in the book that you can memorize, which is actually kind of annoying, but you could memorize the things in the book as far as like, hey, when will a degenerate appear? Or you could just practice what we need to know anyway. Oops, it wasn't a plus. You could just complete the square and make sure it's not a 0. You should be able to guess it's a circle. But why am I putting a question mark? Gotta watch out for those degenerates. They're pretending to be things that they're not. So life lesson in there somewhere. But moving on, I should say. What do we got? Y squared minus 6y. All we really care about is the other side, but the other side, don't we have to figure out what happens when we put in? Now hold on. If we add a number, is there any way it's going to get to 0? So we're okay. There's no way that can get to 0. There's no subtraction going on. But if you want to, you could go ahead and double check. That's going to be a 4 and that's going to be a 9, right? Cut in half and square, cut in half and square. There's nothing on the outside, so that's a 4, that's a 9. Is that 0? No, I'm good. Whatever that ends up being, I can divide on the other side. I can get it equal to 1 and I'll be good to go. Kyle. Is it pretty? Ooh, that's nice. Except there are no extra coefficients. So when I divide it, this guy and this guy, even though the center is different, that's okay. Radius is the same. It looks like an ellipse, except the numbers are the same. So can't I just have 36 and it's x minus h squared plus y minus k squared equals r squared because they're the same thing? Does that make sense? Kim? They're actually, well, they're solving it. Remember I said that in the book. Actually, let me come over here. See that those A's and C's? What I was saying a second ago is there are things that you can memorize as far as what will happen. See, you can memorize some things if you want. The only dilemma is we have to be really careful as to this. And I don't know, I don't like making you memorize more things than you have to if there's a way of figuring it out. So Kim, it's up to you, this way or the other way. And for the rest of you guys, my memorizing people, this will tell you without you having to complete the square whether an equation in this form is, which of the different conics. And if some of these, like for instance, for the hyperbola, if this isn't true, it's a degenerate. But if you try solving it, which I might ask you to do somewhere else on the test anyway, write it in standard form. You're going to have this skill set anyway. I don't know. My brain would rather just do this and know rather than memorize this and be like, well, I hope I memorized it right. Does that make sense? But you guys have to choose. There you go. You could do the exact same procedure with 56, 62, and 66, but these ones were nice ones. The evens were nice ones. No degenerates. Did I give you any odd degenerates?
No.
Ugh. Well, good thing I gave you one in your notes, so you've seen one. Not saying I will definitely do that on the test, but I could. Robbie. Yes, now that we finished grading. We finished grading, right? Got to the end? Okay, cool. Okay, cool. Any other questions for me? Yeah. Yeah. You got something different? Let me see. Can I just go straight to factoring? Is that okay, Kyle? Hold on. Any more room? Plus. Ooh, that's a big number. Let's see if we can counteract it. Well, hold on. Half 10 is 5. 5 squared is 25. 25 and 9. 9 quarters is 225, right? And then half of 2 is 1 squared 1, and that's 4. Woo-hoo-hoo-hoo, that was close. 229 and 228 equals 1. Not degenerate, though. Well, wait a minute. What did we do? Remember those weird ones where we can say multiplying by a fraction? No, sorry. Multiplying by is dividing by. It's going to be itty-bitty little ones. One of those itty-bitty little ones. Because multiplying by 4 over 1 is dividing by 1/4. Oh, sorry. I already have equals 1, but that's okay. Even though it's weird. It's an ellipse. All right, any other questions on odds or evens? Boop. Tony, start with point slope. Start with point slope. So when you have this, remember for the asymptotes. In class, I just talked about the slope. And I need plus or minus rise over run. So for rise, I look at the y's. So that's why I'm going to choose 5. And the run, I'm going to look at the x's, horizontal, vertical. Square root is 12. But then I have to go ahead and say y minus y1 equals m x minus x1, point slope form. And where are the asymptotes being measured from? In all of our examples, where are they being measured from? Center. So I use the center as my point. So I use -3 and +2. And I have a hair, either that or a bug. Does that make sense? Yeah, use the center for your asymptotes. And that should match up with, yeah. All they did is they just moved to get y by itself. Any other questions on homework? Okay, we have a test coming. I'm going to do Kyle's question, but some of you homework has been super hard. Some of you homework has been in between, but most of you have been referencing over and over again your what? Does this test need some memorizing? Yeah. Maybe the formulas, maybe the pictures, maybe all the different variations, or maybe just the standard forms and how to get it. No matter what, for C's, for A's, for B's, for standard forms, is there memorizing for everyone that's required? Yeah. So I need you guys to think about, how did I do homework? How did I get homework? What did I need to be able to access with my eyes? And then think, I need that internalized, memorized by Thursday. Make sense? Kyle, what was your question?
Number 56. I got the level, since they're not showing me the actual answer, I just changed that. What is this? I got 3 plus y minus 3 squared over 4.
Oh, because you're trying to get the standard form real quick? You would have completed the square. that'd be minus 12, right? So then take out 4, that'd be minus 3, and that'd be y minus 3 squared. Oh, it's getting x by itself. But this is our standard form, remember, with the 4p? But yeah, if you were to, you could divide by 4 and add 3, or you could just leave it like this, because this is my y minus k squared equals 4. Well, p would be 1, right? But either way, 4p x minus h. So yeah, either way. Old standard form, you would have divided by 4 and added 3. New standard form, you could have stopped there. All right, cool kids. With that, let's get back to our quadric surfaces. All right, Jason, you have one more try. Stay awake. Let me pop open the door too, because it is a little warm and that makes it hard. Jason, why don't you take off your jacket? You'll be not as warm. Help you stay awake better. Jason, why don't you take off your jacket? Maybe if you're not as hot. Because it's warm in here. Okay, section 12.3a. You know what yeah, we'll just stop. Okay, you should have notes started on 12.3a. Let me show you guys something really quickly in your Google Classroom, yeah? Because 12.3, isn't it in a different book? All right, so check it, good, check it. I have, wait, does this look like homework? Or does this look like an actual section from a book? Oh, so I attached the actual section from the book because you guys don't have the book to have the section. Does that make sense? So I have the entire section from the book, including examples. And there's even like this whole like, ooh, there's a shape within a shape. Ooh, that gets exciting. Okay. Oh, what else don't you have if you don't have the other book? The answers to the odds in the back of the book. True? So, not only do you have here, attached to the assignment in Google Classroom, the actual section from the book to refer to, etc., so you have something beyond our notes, but you also have the answers to the odds of homework back there as well. Now, what do you have besides that? The homework. The actual homework that you're going to have to refer to. But that's kind of nice. Like, okay, there are the homework problems. Don't even need to take your book home tonight, right? Tonight or tomorrow night. Unless you need to be studying things for the test on Thursday and it's in your book. Hey, does this homework look brutal? Ew. This was the old HPrecalc book, before I adopted the one that, the one that you have now. It was actually quite a bit different, and that was quite a bit easier to carry around. Wow, that would have been nice. But do you guys see what kinds of problems were in these homeworks? A, B, C, D, E, F, G. Yeah. Let's just say, very first chapter, whenever I taught this book, kiddos did okay until like section, what was it, 1.4? Yeah, they were okay until section 1.4. And then section 1.4, like, why are there only words? Now, it was math, but it was like A, B, C, D, A, B, C, D, A, B, C, D, E, F, G, A, B, C, D, A, B, C, D, E, A, B, C, D, E, F, A, B, whoo! Now, it was a great book. It made them think. It made them read. It made them work. It made, well, you really had to learn English in order to be able to do math. Oh, that's a struggle. It was a great book, but it was a little bit intense. And actually in section 1.4, chapter 1, section 4, you shine a flashlight, making a circular spot of light with radius 5 centimeters on a wall. Suppose that as you back away from the wall, the radius of the spotlight increases at a rate of 7 centimeters per second. That was section 1.4. Our book spreads it out. So, is it harder to carry around? Yes. Is it harder to make nice and not have like the covers be falling off? Yes. Is it sometimes annoying that our problems go up to like 120? Well, I don't know. Something high. Yes. But would you rather be doing this book? Most of you know. Oh, this section looks fun. What's this section? Identifying functions from numerical patterns in tables. Add, multiply, multiply, add, multiply, multiply, add. I think you guys actually do this in algebra too. But check it. Ready? Oh, there's some tables. Not big, right? Not a big deal. ABC for all of those ones. And then all of a sudden, whoo! Okay, that was fun stuff. I actually remember some of these problems. Oh yeah, there was Gulliver's Travels. I remember that one. But see, look at how short that was, right? But the problems, they were like, And there was no calc chat. Cheaters. Anyway, here we go. You guys see what's in your Google Classroom, true? Okay, let's get back to notes. But anyway, from that book, I do love this section. I mean, there are lots of good things with that book, and to be honest, you would probably be better critical thinkers if we had stayed with that book. But some of your skills would be weaker as far as your mathematical skills. Algebraic skills. Yes, question? I had that like my first 3 or 4 years of teaching. By my third year, they kind of like knew me, trusted me, wanted to take my class, so most of them would stay in. But like the first, second year, yeah, people got scared by the end of the first chapter. They did. But now this book feels a lot more like the Algebra 2 book, right? Like they kind of feel similar, so it's not as weird and as different. But before, yeah, it was definitely like we have to read for math homework, which you should be doing anyway. Okay, section 12.3. You guys started this on Friday, right? How did I describe the surface versus the solid? Surface is like the outer. You can kind of think like surface area. Wasn't that a thing you learned in geometry? Well, not even geometry. It was like middle school math, right? The surface area of a shape versus the volume of the shape. So surface region, we can think surface area. Solid region, we can think, well, it's solid. Can I just put volume? Is that okay? Solid region, everything inside. So when I drew, for instance, a parabola. Wait a minute, didn't I talk about something like I can't have it literally going on forever, because if I have it literally going on forever, I can't actually draw it. And I rotate it. Wait, I'm rotating? Yeah, you are. I'm rotating around. Ooh, paraboloids are formed by rotating around its axis of revolution. That's what I call it now. It used to be called axis of symmetry. A paraboloid is formed when we rotate about. Did you guys see me do rotation arrows? Okay. Super important that you show that. On the test, there are going to be problems where I tell you, revolve it about this. Rotate it about this. And if you do the wrong one, you'll get the wrong shape. But paraboloids are formed. Paraboloids are what happen. It's like the bowl, it's like the cup. When you form a parabola that's been cut off somewhere, that's been stopped somewhere, when you rotate that about its axis, it means the parabola, its axis of symmetry. Are we okay? So we're going from a two-dimensional parabola, we're taking it out of the picture and we're spinning it. Paraboloid. What else did we get to, though? Did we get to ellipsoids at all? Oh. All right, ellipsoids. What's going on? Ellipsoids. There are 2 different types. You guys see I just zoomed in. There were 2 different types. Okay. Prolate would be one that's formed when revolving around the major axis. And I'm going to go ahead and, what do you guys want? It's up to you. I don't care. Do you want a horizontally oriented one or a vertically oriented one? Okay. So if it's horizontal, then the x comes first, right? Middle school must have just gotten out of chapel. We still have another minute, 2. So if I were to go out like an A, then go up like a B, you guys see how A is bigger than B, right? And if I was to draw that ellipse, it's a little rough, but we get the idea, right? One way of doing this, spinning, is around the major axis, and the other way of spinning is around the minor axis. One way of spinning is around the major axis. One way of spinning is around the minor axis. So let's see the difference. And I could have done this vertically too. It's the major. Well, hold on. The major is the longer. So in this one, isn't the longer the horizontal one? And this one, isn't the minor the vertical one? So what happens? Well, if I spin it this way, do you guys see how I basically get like a Like a pill? Like a minion? Like a football? Kind of, just not with a little. I'm spinning it. And it's self-contained. As long as my hand was, I don't know, whatever this distance is away from the board, I'd be safe. It could be spinning, 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 spinning. But what if this one were to spin? Do you guys see how if this one were to spin? And I know some of my artists, you could do this a lot better than I could. It's like a fan blade. It's like a cheese wheel. It's like a pillow. Because this one's all nice, self-contained. Like a pill, like a minion, like a football. This one, when this one swings out, could do some serious damage. Now I'm just showing a rotation arrow. My perspective is a bit rough. I probably should have drawn my z-axis, but whatever, you get the idea. This one is like a fan. Foom, 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 foom. This one is like one of those circular pillows that some of your, I don't know, parents might have like a chair or something. This one is like, I don't know, I guess a cheese wheel. I could have some fun. I could have it go the other direction too. But then this is where I really start to, my lack of artistic training is a bit rough. You could have it go the other way. Yep. But my ones who are not artistic, they're like, I can't do that. Okay, ready? See this guy? This is why I have you drawn. If you just do this, or this guy, if you just do this, maybe you should do a little better than that, but I'll know what you're talking about. Prolate, oblate, prolate, professional football, oblate, obtuse, wide, I don't know. Bye guys, see you later. We have to do hyperboloids tomorrow. But guess what? Homework starts with, well, look, a paraboloid. Look, an ellipsoid. Ah! But don't we have to graph the specific one and then spin it? So you're going to be practicing all of section 10.1, 10.2, well, 10.2, 10.3, 10.4, as you do 12.3. Bye, guys. We'll finish it up tomorrow. So if you want to, you can graph all the two-dimensional ones tonight, and then we'll learn how to do the three-dimensional ones tomorrow. Bye, guys.